Risha. So just see, so we were talking about the alkenes. Okay, so their general formula is CnH2n. Is it visible now clearly? Okay, so first member is ethene. First member is ethene. So that is what? CH2 double bond CH2. Then the second member is propene. Propene means 3 carbons. Should I show you? Just see, I am clearly showing you 3 carbons you will draw. Okay. So to any place, either this side or the other side, you will draw the double bond and then satisfy the hydrogens. Clear that thing? Representation is clear or not, or any kind of doubt if it is there, just tell me. Just see. So this is our propene. So if I compile and write, so what we are going to get? CH2 double bond CH CH3. So this is propene. Clear, Anvesha? Is it clear, Anvesha?
Yes, ma'am. Yes, ma'am.
Now next is butene. So butene, now as there are 4 carbons, so let us draw it. Okay, so either side, from any of the side, either the left hand side or the right side. So then we will write the hydrogens. So H2, this side H, again CH2 and CH3. So this is butene. So this is basically, you can say, one butene, because at the first place there is a double bond. Just see, first carbon there is a double bond. So it is basically one butene. Okay. Now let us talk about 2 butene. So there is, again you will draw 4 carbons. Okay, at the second one we are going to draw a double bond, and the rest of the places we will write the hydrogens. Rest of the places wherever it is needed to satisfy the valency, we will write the hydrogen. Clear? Now you try to draw 2 pentene. 2 pentene. Draw it. Yeah. CH. Okay, in between the second and the third carbon you have drawn, it is not visible clearly. You have drawn in between the second. Yes, correct. Once I will draw there also, because I was not able to show clearly, see very clearly that thing. Just check. You have drawn in this way?
Yes, ma'am. Ma'am, actually I wanted to ask that the assignments which have come on the Google Classroom, where we have to submit them?
The assignments or the
Yes,
PPTs?
PPTs and the assignment and worksheets.
There at the Google Classroom itself better.
Okay.
Yeah.
Then just see, say you have CH3, okay, and a double bond here, then hydrogen, CH2 and CH3. Try to name it. First check that from which side we should number.
Ma'am, from the right side we should number it.
Okay. In this way?
Yes, ma'am.
Okay. So try to name. Should I help? Now whenever there is a CH3 group present, that is known as what? Methyl.
Methyl.
So CH3 group is methyl. C2H5 group is ethyl. Okay. One hydrogen. You have just see CH3 how I got? By removing one hydrogen from it. No. So that is methyl. If you have C2H5, that is ethyl. If you have C3H7, that is propyl. Okay. So what is the position of this CH3 group? That is, CH3 group, that is 2-methyl.
2-methyl pentene.
Yeah, very good. 2-methyl pentene or propene or butane?
Propene, sorry.
No.
Propene.
How many carbons in the parent?
They have 5 carbons, ma'am.
No. You will see only the longest chain.
Longest chain has 4.
4. So that is the parent. That is butane. Got it? So
Yes,
you will see the longest chain only. So this is your this one. This one is the longest chain. No. So this contains 4 carbons. Got it? So try to name one more. Just see. So say you have CH3, CH2. Longest chain have how many carbons?
Longest chain have 6 carbons.
So it is position of
the position of that attachment is 3, so we'll say 3-methyl hexene.
very good, super. Okay. So now just see if I remove this hydrogen and attach one more CH3 group to this, then what will be the name? Then remember, when there are 2 methyl groups, so then you have to, one I am helping you out, so you will write 3, 3. 3,
Okay.
3.
Okay.
Dimethyl.
Yes.
Okay. So 6 are there, so hexene.
Sure.
Okay. So this place to which the CH3 is attached, it is known as locant site. What is that known as?
Locant site.
Locant site. Okay. So one more example I am just giving you. Just see. Try to do that. Say you have CH3, CH3. Try to name it.
Ma'am, it's 2,3 dimethyl pentene.
Clear this thing now? Now next
Yes.
I am moving toward the structural isomers. Isomers on that day I have explained you. I have explained isomers? No.
No, ma'am, you haven't explained.
Okay, so just see isomers. So isomers are basically what? These are the compounds. These are the compounds with same molecular formula. Compounds with same molecular formula. Same molecular formula, but different structure. But different structure. Their structure are different. These are the compounds with same molecular formula. Molecular formula will remain same, but their structure are different. Okay. So here in the case of alkene, two types of isomers are possible. So that is what? That is chain isomer, and second is the positional isomer. Chain isomer and positional isomer. So basically what here you will see that the chain is, say, this one isomer is, imagine that this one. Okay, so double bond, position of the double bond is at the first, with the first carbon. Another isomer will be only the position of the double isomer we will change, or chain we are changing. Just see how many carbons are there. My handwriting is becoming poor in this actually. Wait.
No, ma'am, that was understandable.
You are able to understand. I am drawing the bond line structure otherwise. Just see. Okay, so here there is a double bond. Okay, how many carbons are there? Just count.
7.
Counted already? Very good. So I will keep the number of carbons same. Say 1, 2, 3, 4, 5, and I am keeping one carbon here and other carbon here. So number of carbon, this is one carbon, it is clear now. This is one carbon and this is another carbon, and there is a branch here.
Yes,
Sorry, double bond here. So just see, the molecular formula remains same. That means 7 carbon and 1 double bond. Here also, in both the cases, here also and here also, the molecular formula remains same, but the chain length is changing. So they are known as chain isomer. Is it clear? Okay.
Yes, ma'am.
Now another thing what I said, that is positional isomer. That means position of double bond will change. Here just see, when I was drawing, I have not changed the position of double bond. It is at the first carbon only. It is with the first carbon only.
Yes,
Now imagine that if I change the position of the double bond only. Just see. Now here what is the position of the double bond? To which carbon?
it's in the third carbon.
Very good. So this is going to be hept 3 in.
Yes, ma'am.
The earlier this one is hept 1 in and this one is hept 3 in. Clear this thing?
Yes,
Okay.
ma'am.
So position of the double bond is only changing. So these are chain isomer and positional isomer. Is it clear? Isomers are clear. So what are isomers? How you will define?
The compounds which have same molecular formulas but different structure are known as isomers.
So in alkenes they are of two types, chain and the position. Okay. Now another type of isomers are possible in the alkene. They are geometrical isomers. What are they? Geometrical isomers. So in the case of geometrical isomers, means their structure is different again. How it is different? Just see. So say you have C double bond C with one CH3, another CH3 this side, and hydrogens I am writing in this way. Okay, so can you name this compound? What is the name of this compound? Try it. We have done this one or no? I don't. No, we have done.
ये वाले तो नहीं किए हैं.
अच्छा नहीं किए थे. लॉन्गेस्ट चेन क्या दिख रहा है?
Longest chain मैम CH3C double bond CH3.
तो ये वाला फर्स्ट कार्बन है, सेकेंड, थर्ड एंड फोर्थ. तो क्या नाम होगा इसका?
मैम इसका But2ene.
But2ene, करेक्ट. But2ene. So But2ene को ये जब when both the CH3s are on the same side, both the CH3s are on the same side, so that is known as cis. That is known as cis. Cis isomer. So what you will write? Cis But2ene. Cis But2ene. Okay. And
Yes, ma'am.
and when both the CH3s are on the opposite side, then it is known as trans. Trans. Trans But2ene. Cis But2ene and trans But2ene. Okay. Cis when both the CH3s are on the same side, and trans when both the CH3s are on the opposite side. देखो अब ट्रांस में देखो कि ये CH3, this CH3 is giving electron, this CH3 is going to give electron because CH3 have a tendency to give electron. Okay, this CH3 is also going to give electron, but दोनों side से they are giving equally the electron to this carbon. It is giving equally electron to these two carbon. Okay, so you know about the polarity. We have discussed most probably, na? Bond polarity.
Don't remember.
HCl is polar or H2 is polar. We have had a discussion about that. HCl, H2O. Remember that?
Yes, ma'am. We discussed it about it in the demo class.
Okay. So just see very fastly. Just see. If I talk about HCl, okay. So Cl is what? Electropositive or electronegative? Cl is what? Halogen? Halogens?
Yes, ma'am.
So they have a tendency to take the electron. Okay. Halogens, they have a tendency to take the electron. They have a tendency to pull the electron toward themselves. So they are negative, remember. You remember periodic table. You know the periodic table?
Yes, ma'am.
So halogen belong to the right side of the periodic table or left side?
Ma'am, halogens belong to the left side, right side of the periodic table.
Okay. So left to right in a this periodic table, left to right in a period, the electronegativity increases or decreases?
Ma'am, from left to right, it increases.
It increases. No, because the size decreases. So chlorine belongs to the left side, as you said. Left to right.
No, ma'am, it belongs to the right
side. Right side. So left to right it increases. That means chlorine is going to be electronegative or positive?
Ma'am, it is going to be electronegative because it has a tendency to gain electron.
Yes, yes. So chlorine will develop a negative charge when attached to the hydrogen. And hydrogen, as it is on the left side, so it has a tendency to give electron. So it will develop a positive charge. So what is happening? These two are becoming two poles. One is the negative pole and other is the positive pole. Is it clear?
Yes,
So
ma'am.
such compounds are known as polar compounds. Clear?
Yes.
If I talk about hydrogen molecule, H2 molecule, then I will draw it in this way, H and H. No. Now both of them are what? Electropositive in nature.
Yes.
So both will have the shared pair at the center. Whatever they will share, that will remain at the center here only. Neither toward this hydrogen or not toward this hydrogen. It will not go anywhere. It will remain at the center. So such compounds are what? Non-polar. Such compounds are non-polar.
Non-polar.
Clear? Now just see where I was explaining this trans-but-2-ene. Here what is happening? Both the CH3 are giving electron equally. So their polarity is getting cancelled and trans is becoming non-polar. Okay, because equally they are giving electron. Here what is happening? The CH3 is giving electron. This CH3 is also giving electron. Okay, so their polarity is not getting cancelled. That is coming in one direction only. It is coming down.
Yes.
The total polarity, if I mark, it is in this way. Okay, so total polarity is in the downward side. So its polarity, so this is what basically cis is polar. This one is polar. Okay, cis is polar. So anything which is a polar have a high melting point and boiling point. So boiling point of cis is greater than the trans. Boiling point of cis is going to be greater than the trans. So what you came to know? Cis is the isomer when both the similar functional group are on the same side. Similar groups are on the same side. Trans is one in which the similar groups are on the opposite side. Trans is non-polar and cis is polar. Okay, and hence the cis is having more boiling point. Got it?
Yes.
How much you have understood? Tell.
Ma'am, when two functional groups are reacting on the same side, they are known as cis isomers. And when two functional groups are reacting,
Purple West offers personalized one-to-one classes with customized content for each student, designed by proficient academicians and student psychology experts. Our teachers hold at least postgraduate or PhD degrees and have an engaging way of teaching. Purple West, homeschooling and digital coaching.
in the opposite direction, they are known as trans. The trans isomers are non-polar and cis isomers are polar. That is why cis isomers have more boiling point as compared to the trans one.
Very good. Okay. Now let us talk about the preparation. Preparation of this alkynes only. Alkenes, sorry. Preparation of alkenes. The preparation of alkenes from, first we are going to do from alkynes. From alkynes. Okay. So for example, alkyne means triple bond. So you have triple bond. So basically just see, if you have a triple bond, how you will get this one? How we will get CH2, double bond CH2? What I have added, can you find out? What is the difference between this ethyne and ethene? What is the difference?
There is a difference of how you have added a hydrogen.
Yes, addition of hydrogen. So let us add. As Anvesha is saying, I am adding hydrogen. Clear? But hydrogen should be added in the presence of a catalyst. Otherwise, you have to supply heat and pressure and all. So we will apply a catalyst. What is that? PD and C. What is that? PDC.
CD and C.
PDC is basically what? Palletized charcoal. What is PDC? Repeat it 5 times. It is very important.
PDC is palletized charcoal. PDC is palletized charcoal. PDC is palletized charcoal. PDC is palletized charcoal. And PDC is palletized charcoal.
Palletized charcoal. So palletized charcoal is also known as Lindlar's catalyst. What is that? Repeat it. Lindlar's catalyst.
Lindlar's
catalyst. Yeah. Lindlar's catalyst. This is very important actually, and for the NEET purpose also. Okay. Palletized charcoal, Lindlar's catalyst. Palletized charcoal. Okay. Which we use for adding the converting the triple bond into the double bond. Now just see very carefully. When you add palletized charcoal, so say as I said, you have CH triple bond CH, and we are adding H2. I am writing the same thing again, that is PD and C we are adding. Then there is always the chance, it is being experimentally observed, that we get cis product. What we get? We get cis alkene. Okay, there are chances always that we get cis only. So this is experimentally being found. There is no such any theoretical this thing that why we get the cis, but yes, when we add palletized charcoal, we get cis alkene only. Okay, so how to get the trans one? That is, if you have CH triple bond CH and add H2 in the presence of Na and liquid ammonia, that is NH3, then there is always the chance of getting a trans product. So you will get a trans. Okay, Na, sodium and liquid ammonia, then we will get the trans one. So this is applicable only for the ethenes. Now if I will talk about propane or butane, nothing like that, you can directly add the palletized carbon only. Is it clear? Are you writing or you will write later on?
The things which I'm thinking I won't be able to write later, that I'm writing them now, and rest of it I'm taking a screenshot in my laptop.
Okay, okay. But write those things also later on. Should I proceed?
Yes, ma'am.
Okay. So just see, if we talk about butane, that is CH3, C triple bond CH. Propane. So same, H2 and PD and C you can add. Similarly, if you have CH3, C triple bond C, CH3, that is 2-butane. Same process, H2, PD and C. So what you are going to get here? First one.
First one we are going to get a...
Draw it and show me.
Ma'am, I'm not getting it. Can you please explain the first part?
What we are doing, Josie? You only told me the earlier. Observe and tell. What we are doing? Converting what to what?
We are converting ethyne to ethene.
Yeah. So means, just see the same thing. So simply you are doing what? Adding hydrogen or not?
Yes, ma'am.
मैम नहीं हो रहा क्यों? हाइड्रोजन ही तो ऐड करना है. कहाँ पे देखो? You will only try and do it. So that's why you should go on writing with me. Just see. This one. Carefully just see क्या हुआ है. How many hydrogens थे? कितने हाइड्रोजन हैं?
3.
यहाँ पे कितने? नहीं, यहाँ पे कितने हाइड्रोजन हैं?
यहाँ पे 2.
2 है. और कितने कार्बन्स हैं?
There are 2 carbons.
तो यहाँ पे क्या हुआ? वेरी केयरफुली जस्ट सी. कितने हाइड्रोजन थे और कितने हाइड्रोजन हो गए?
2 थे, 4 हो गए.
तो 2 थे, तो दोनों को एक एक कार्बन में यू हैव अटैच्ड so that the double triple bond got converted into double bond. Yes or no? So
Yes.
do it here. The same thing. Just see. Carefully just see how many hydrogens are there. 2. And you have 2 carbons. One this and one this. You have to remember tetravalency of the carbon to be maintained. You have to write everything actually in the class. Then only you will come to know that where you are having the problem. Show what you are doing. Where is the problem? Then I will come to know. Yes, correct. You are hesitating only, nothing else than that. Correct, Anvesha? That is absolutely correct. Do the next one also. You are afraid, no? डर लगता है करने में.
I am not afraid. I have lack of confidence.
Okay. So don't worry. You have done the absolutely correct thing. Done? Yes, that is also correct. Great. So if I give you in words now, the same thing I am going to give you in words. That is convert pentine to 2-pentene. Draw the structure and then do it. Show me the structure of 2-pentine.
Just a second, I'm sure.
Done. Where you are stuck, show me. It's not visible at all. Now you have to bring it more close to the other camera. Not visible. You are holding at a wrong place. Just see. I am drawing it because I have to go to the other class also. Just see carefully. C, triple bond C, CH2, CH3. 1, 2, 3, 4, 5 carbons are there. Triple bond is there. So simply H2, PD and C. So you have drawn the pentine in this way only or not?
Yes, sir.
Okay.
Yes, sir.
So practice the things. Again and again just write it by your own.
Sure, ma'am.
Okay.
Okay.
Okay. Okay. Bye.
Bye.
Bye.